Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over the JavaScript Boolean operators as well as how JavaScript handles Boolean assignment. Let's get right into it. Alright, so I'd like to start this video off with a diagram. In this case, a table, I guess, technically. I've created a table of all of the Boolean operators we have in JavaScript today. I've highlighted the ones that I recommend us not to use. I will spend just a tiny bit of time on those just to mention kind of why. And then down here, I have a kind of a new addition to the language. So let's go right through these one at a time. A Boolean operator in JavaScript is something that is going to take values and give us back a Boolean value in return. So, for example, we can compare values with each other, like is the number 5 equal to the number 5? And that would be true. If we asked if the number 5 is equal to the number 4, that is, of course, not true. So we can kind of combine these different questions and pose them to the computer, and they will give us back true or false values in return for those questions. So starting off, that exact question that I asked is something equal to something else? That's this one right here, the second one, the second row. So why do I have this double equals? Just really quick. This is common in a lot of other languages. So if you're coming from another language to JavaScript, it might kind of seem bizarre that we have a triple equal sign. This is mainly a historical kind of accident. JavaScript is, I guess, quite loosey-goosey with the way that it treats equality. So different versions of the language, especially as it kind of matured and grew up, it had to add this idea of a strict equals. And we can go into the differences of that in a future video, but that is a totally separate topic and beyond the scope of this video. So if you're interested in that, please leave a comment on the video and we can discuss that together. So that said, try not to use the double equal sign or the bang equal sign, which is the opposite of not equal to. Those are probably going to cause bugs in your code, and you just generally won't see them in many code bases at all. What you're going to see instead is a more modern, I guess, replacement for those, or the strict replacement for those technically, which is the triple equals and the bang equals equals, which is the not equal. So that said, this equals equals equals, 3 equals in a row, is a strict equality check. It's asking, is the left-hand side equal to the right-hand side? So is 5 equal to 4? That's false. Is 5 equal to 5? That's true. The bang equals equals is a strict not equal. So it's the opposite of the one I just mentioned. It's asking, is the left-hand side not equal to the right-hand side? Or is the right-hand side not equal to the left-hand side? It kind of goes both ways. These next 4 here, might be a bit more familiar if you've done mathematics before. This one here, the first one, is the greater than symbol. So it's asking, is the left-hand side greater than the right-hand side? So for example, is 5 greater than 3? That would be true. This one below it, the second one, is the less than symbol, which is checking the opposite. It's checking to see, is the left-hand side less than the right-hand side? The next one here is greater than or equal to. So this is including kind of an equality check. So we'll see a lot of examples as to kind of the differences between these, but this is just one extra small case where if they're exactly equal to each other. So for example, 3 is not greater than 3, but 3 is greater than or equal to 3. That's true. All right, and then less than or equal to is the same thing, but on the left-hand side. So left-hand side less than or equal to the right-hand side. And then we have these funky ones down here, which are known as the logical operators. This first one here, ampersand is logical AND operator. The pipe is the logical OR operator. And then this new one here, question mark, is called the Nullish Coalescing operator. It's quite a mouthful. That's a bit newer to the language and kind of fixes quote unquote some quirks that might be an issue with either of these, which we'll get into as we start coding. So I guess enough with the concepts. Let's just get right into the code to see how these actually work. So go ahead and pull up Visual Studio. I'm just going to create I opened up a new folder already. I'm going to create a new file. Just call this Boolean operators. So let's go through these one at a time. We'll go with the strict equality. So I'm going to console log some statements and see what they actually give us in return. So for example, if I ask the question, is 5, and I'm going to do triple equals here, 3 equals in a row, 1, 2, 3. I should probably mention before we go further, my editor is set up to do this thing called ligatures. I'll just spell it out, ligatures. You can check in the Visual Studio Code settings to see if you can turn that on and off, depending on if your font supported or not. That just adds these funky looking symbols, but this is really just the 3 equal signs jammed together. Okay, so when you see that, that's how that works. I'll point out a couple others that it does for me. Just makes it look a bit nicer and more compact. So 5 triple equals 5. This should be true because the left-hand side is exactly equal to the right-hand side. They're both the number 5. All right, so I'll open up my sidebar here, and I'm just gonna make sure I'm in the right folder by doing an ls, and I'm gonna do a node and then Boolean operators, and I get true. All right, great. So that means that this is working, and we're not wrong about this, which is fantastic. Let's see kind of the opposite, right? So what happens if we do, like, let's say something that's not true. So is 5 equal to 3 equals 4, right? This clearly is not true, right? Because 5 is obviously not equal to 4. They're different numbers. So if I run this, you'll see that I do get false, right? So these are the only 2 possible values for Boolean operators. They can only give us true or false, one or the other. And just to kind of really hit this home, if I flip these around and I do 4 triple equals 5 like this, so in this case the 4 is on this side, 5 is on this side, in this case 4 is on this side and 5 is on this side, it doesn't matter, right? It's just checking to see if they're equal to each other. And you can see that this is also false. Okay, great. So that's strict equality. Let's do strict not equal next. I'll just clear my console here. So the way that this works is the bang operator or the exclamation operator, and then 2 equals. My editor, excuse me, again is going to do kind of some funkiness with this to kind of put an X through it, but your editor may or may not do that depending on if you have ligatures going in your settings. If you need help with that, please feel free to mention that in the comments, and I would love to help you out. So bang and then equals equals is what I'm going to be typing. Bang equals equals. You can see if I split these out, it's just bang equals equals. All right, so I'm going to say the same things. Is 5 not equal to 5? Well, 5 is equal to 5. So is 5 not equal to 5 is the opposite, which should be false, right? I'm just going to put a console log here as well so that I can do a little bit of a kind of separator, just like that. If I run this file, you'll see that I get false, right? Which is different from what we got here. It's in fact the opposite, okay? Because 5 is not equal, is equal to 5. So checking if they're not equal to each other should be the opposite, which is false. In this case, you can imagine if we do these other statements here, 5, is not equal, bang, equals 4. This used to be false, so now we should get true, right? Because 5 is indeed not equal to 4. And if we flip this around, if I do 4 not equal to 5, then that should also be true because these are not equal to each other. So if I run that, you'll see that I get false, true, true, which is the exact opposite of what we had above. All right, great. I'm just gonna copy this and I'll put this here and I'll do greater than and then less than and greater than equal to and less than or equal to. So these are the Boolean, I guess the mathematical operators. I'm putting in quotes because technically they can be used without numbers, but we'll see kind of how that works. So if I want to check if something is greater than or less than another thing, we can use this operator. So for example, if I want to check the number 9, is that greater than the number 7, right? That should be true. So if I run this, you'll see that I get true, right? If I want to check if is 6 less than the number 5, right? 6 is not less than 5, right? So this should be false. And indeed we get false. All right. If we want to check, is 3 less than 3? This is a bit tricky, right? Because 3 is not less than 3, it's equal to 3. So is this going to be true? Is it going to be false? Turns out it's going to be false, right? Because strictly speaking, 3 is actually not less than 3. If we wanted to check if they're also equal, this is where these two operators come in. They're equal to of the greater than and the less than version, right? So if we said console.log is 3 less than or equal to 3, then indeed we would get true for this. And you can see that we get true right here. I know this is bleeding off my screen with my little bubble, but I think you should be able to see that. Okay, so similarly, we can do console.log is 4 greater than or equal to 2. And this should be true because 4 is actually greater than. We don't even need the equal to in this case, but it's just nice to have if that's what we want to be checking. Okay, so that's pretty much how I want to explain these ones over here, which are of the most common ones that you're going to see directly. And we're going to see this a lot when we look at something called conditional statements or if statements. Again, I just want to caution, don't use these ones, the ones that I haven't read, the kind of loose equals or the loose not equals. There's a lot of cases where you'll end up in trouble and a lot of bugs will happen if you end up using those. Just get used to using the triple equals or the not equals equals. Okay, so the logical and logical or, these look really weird, right? So what is the point of these and how does it differ from these other guys over here? It turns out that there are going to be cases where we're going to want to check to see if different conditions can kind of answer more complicated questions. And what I mean by that is maybe you want to check if one thing is true and another thing is false, or if one thing is false and another thing is also false, or if both things are true, right? There can be an infinite number of cases that we can start generating if we can start doing things like this, because then we can start chaining them together and we can actually create very, very complex questions. In fact, we can actually create any question that can eventually evaluate to something that's true or false. So let me show you what I mean by kind of going into a pretty central concept in computer science, which is called a truth table. So for and, which is the ampersand, this is what's called the and truth table. And this is just showing what happens when we have a left-hand side and a right-hand side, and we put the ampersand in between them. The and operator takes a Boolean value on the left and a Boolean value on the right. And then it does this and operation thing on them, which is a special operator, and it gives us a result depending on the combination of those values. It turns out that if you have two things, you can have 4 potential values, such as this table right here. All right. So what does that mean in detail? Let's say that we have something on the left that's true, and we have something on the right that's also true. So we had true and true. We would actually get true. Interestingly, these other cases where if we had true and false, or false and true, or even false and false, all of those, when we're using and, evaluate to false. So a simple way of thinking about and is both the left-hand side and the right-hand side have to be true for the whole statement to be true. Okay? I'll give you an analogy right after we look at or together, just so it kind of makes a bit more sense in practice. Or is a little bit more loose. It allows a bit more flexibility in the sense that either the left-hand side or the right-hand side or both can be true. All right. So or is the pipe operator, which is the shift and usually the one above the enter key on your keyboard. And there's 2 of them together. So if we have true on the left and we do or and then true on the right, which is this first line here, we get true. However, unlike and, the cases where we have only one of the values being true and one can be false, we still get true as the entire result for that operation. All right. The only case where or actually fails or doesn't pass the test and gives us a false result is when both the left-hand side and the right-hand side are false. Okay, so this all probably seems like, whoa, like what is happening? This is like way over my head. There's just like, what is all this true, true, false, false, true, false, true, right? This is crazy. This is like computer speak, right? I'll give you a kind of an analogy. Let's say my friend tells me to go to the grocery store, and they say, hey Nader, can you go get us some milk and some eggs, right? If I went to the grocery store and I walk around and I get some milk, and then as I'm going towards the eggs, I know my friend said milk and eggs, so they probably mean both. If I kind of see some candy or some sour keys, which are my favorite, over on the side, then I might get distracted, right? And I might go over there and I forget to get the eggs. So I just get milk and I get my sour keys, and then I go to the cashier, I pay, and I come back to my friend and I say, hey, here you go. I'm so excited. I can't wait to show you these sour keys that I got and then the milk that you asked for, right? I don't think my friend would be very happy because they specifically asked for milk and eggs, right? Which implies that they want both. So maybe they were making cookies or something like that, and now I ruined their day. Although arguably sour keys are much better. However, let's kind of flip that a little bit. Let's just say they said instead of milk and eggs, they said you can get milk or eggs, right? Now this is a little bit different. Now if I went and got milk and I got my sour keys and I came back, maybe they kind of be like, oh, like sour keys, really? But at least you got milk. Like you still passed the test, right? Or I could have just gotten eggs and then the sour keys, and then I could have gone to my friend and given them the eggs and the sour keys, and that still passes the test, right? Because at least I got one of the results, right? Because they said or, okay? So for and, again, hopefully this story helps kind of exemplify this. We need both things for the whole thing to pass the test, to be true. Okay, so in a milk and egg scenario, if they said milk and eggs, I would need to bring them back milk and eggs. I can't just get one or the other, and I obviously can't get nothing. If I get nothing, I've really failed the test, right? But for or, it's a bit more relaxed. I can actually be a superstar and get both of them, and that's fine, and they'd be really happy. I can just get one of them, or I can get the other one, and that's totally fine. The only case where I would actually fail this test is if I don't get anything back, which is fair, right? So that's the way to think about and or. Let's go into a couple of examples. I'll just create a new file over here in my Visual Studio Code. I'll call this and or.js. I'll clear this over here. So this will be and or operators. So if I say true, and then I do ampersand, ampersand, which is and I do true. We just saw that true and true is the only case that gives us true, right? So let's confirm that. I'm going to use node and then and I get true. All right, let's look at these other cases. If I do true and false, or I do false and true, these values are going to be false, right? Which we see is true. If I do false and false, that of course is going to be false because I failed both tests, and I would get false for that as well, right? So you can see that the and the truth table looks like this. Okay, I'm just going to copy this, and I'm going to change this symbol here to the or symbol, which again is the shift and then the pipe symbol, which is the one right above the enter key, just like that. All right, so I'm just going to change these, and I'm going to clear this, and I'm going to run this. Let me actually put a little divider here just so that we can separate these out. So for the or case, you can see that it's a much more relaxed test, right? If both are true, we get true. If one is true, but other is false, we still get true. If the left one is false, but the right one is true, we get true. And then the case where they both fail is the only case where we totally fail the test. Okay, so this might seem kind of like pedantic, or like, why are we doing this, right? But eventually we can combine Boolean statements like less than or greater than on this side, or we can check if something's equal to something on this side, and we can do very complicated questions that will allow us to control the flow of their code as we build more complex applications together. Okay, so that's and and or. There is this one as well, which is the not operator. You've seen that we've used this with the not and an equals equals to check if something is not equal to something else. It turns out you can actually just use not by itself to check something. So for example, I'll put this in the same file just to save some space. If I console.log and I say not true like this, oops, and I console.log not false, and I'm just going to put this divider here as well, and I run this file, you can see that for these bottom two, not true is false and not false is true, right? Quite a mouthful, but what it's doing is it's flipping it. So if we have true and then we not it, we get false. If we have false, then we not it, we get true. And eventually we can put complex statements inside here instead of just true and false, and we can check things like, for example, are you logged in or not logged in, right? We can ask very complicated questions like this eventually as we get better with our code. Okay, so this is the truth table for not. You can see it's quite simple since it only takes one value that it flips. Now, this is an often fraught topic that I found very important to actually put in an introduction to Boolean operators, since this is a source of countless bugs and confusion. It turns out in JavaScript, there are many things that are technically false. This is really annoying and is, again, mainly a historical accident based on how JavaScript was built. But let's go through these so they don't bite us and we can kind of get used to them as we're coding right from the get-go. So all of these values, just to be clear, are actually falsy, which means that if we were to check them to be false, they would be false. Later when we check conditional statements, this is going to come into play very strongly. So these are all technically equal to false. Okay. What are these falsy values? The most obvious one is false. That's actually the base false value in JavaScript. However, it turns out that the number 0 is actually considered falsy, which means it can kind of be false-like. And we'll see where this might get tricky as we build our applications. Also, a string with nothing in it, so just an empty string, is also falsy. This is actually probably even more of a cause of bugs and errors. These two primitive types, null and undefined, those are falsy as well. This is actually useful. We're actually going to use this quite a lot as we're learning to code, and this is definitely exploited quite a lot in the JavaScript communities to check if something is actually not true. This last one looks kind of funky. We haven't seen this one before. Nan is just short for not a number. If you do some really funky math in JavaScript and it does the whole cannot compute thing, it'll actually just barf out this number at you, which is not a number, which is its own special thing like null and undefined. But it is considered falsy as well. So if you kind of do some funky math and you want to check if it's true or if it's false, and you end up with a nan value like this, it's always going to be considered false. So just keep that in mind. Okay. So let's see where these might actually come in the real world. To look at that, we're going to have to learn a quick concept called logical assignments. What we're doing here is we are using the ampersand to evaluate a statement, and then we're assigning it to a variable right away. So what does this mean? This seems really strange. There are many cases where you would definitely want to do this, and we can see examples as we build our code out and we get more practiced, especially with things like web development. But at its core, we kind of have and, we have or, and then we have this nullish coalescing one. So these three are the focus of the assignment operators for Boolean operators. So how does this work? Let's go through this first example together. So we're saying we want to evaluate this statement, true and bananas. All right. The way that this works in JavaScript is for an and statement, JavaScript is first going to check the left-hand side. If the left-hand side is true, it's then going to check the right-hand side because it knows that it has to check both of these to see if the entire thing is true. Because if you think of the and table, if the left-hand side here is true, we want to check the right-hand side to figure out if the whole statement is true or not. We can't immediately kind of discount this statement like these two cases here, for example. In an and statement, if we know the first value is false, we don't really have to check the second value because regardless of if it's true or false, we know that's false. But with an and statement, if the first value is true, we actually don't have enough information yet. We still need to check the second value to see if we get true or false as a final result. Okay, so this is where things get a little bit tricky. Instead of actually evaluating to true and false, when used in this way, we actually end up getting the value that is checked last. Okay, so what does that mean? In this case, I mentioned that the first value is true, and we know that we have to check the second value because we don't know yet whether it's true or false as a statement. So once we're checking the bananas, since bananas is true because it's a not empty string, technically it's a truthy value, that gets put into test 1. However, the funny thing is even if this right-hand side value was false or a falsy value, that would still end up getting put into test 1. So this is where things get a bit tricky, and this is why I wanted to put this in the video because this is actually very useful in a lot of cases, and without a review of it, it might get a bit confusing when you first see it. So to review this, the AND operator when used in this way for an assignment, we first check the left-hand side. If the left-hand side is true, then we have to check the right-hand side, but we return that value and we point this variable at it. Right? So test 1 is going to point to the string bananas. In fact, with the first value being true, test 1 would point to anything that the right-hand side would end up being. So this takes some practice, but that's how that one works. So contrary to that are these false values. So in this case, the left-hand side is false, right? So we don't even have to check the right-hand side because it can't possibly be true as a statement because we know that the left-hand side is false already. So we actually return the value false, and we put that into, or we point this variable at that value, technically, is a way to say it. So test 2 would actually point to false, okay? And to really kind of hammer this, I mentioned 0 is also a falsy value. So when we're checking the left-hand side in this case, since 0 is quote-unquote false, it doesn't actually pass the test and allow us to go to the right-hand side. So 0 actually gets put into test 3. So test 3 is going to point to the number 0 here. Test 2 is going to point to false. And test 1 is going to point to bananas because it did pass this first gate, this first test for the AND operator. All right, this is definitely going to take some time to get used to. So for the first time you see this, you're kind of mind blown. Don't worry. This is an example of a statement where even probably senior developers would get tripped up on. I get tripped up on this stuff all the time, so don't worry about it. Just try to think through the logic, and eventually you'll get better at it as you go. So that was the AND case. Let's look at the OR case. The OR case is a little bit looser, right? If you think of OR, if the first value is true, we know that the entire thing is true right away, right? We don't even have to really bother checking the second value. We know that it's true because as long as you have one that's true, the whole thing is true. However, if it's false, we don't have enough information, unlike AND, because maybe it's possible that the second value is true, in which case we would get true as a statement, right? So this first value is kind of gating the proceedings to the second value. So in the or case, if we have true or bananas instead of and bananas, since the left-hand side is true, it's not going to bother checking the right-hand side. It already knows that this is kind of truthful. So test 1 is actually just going to point directly to true. All right, which is quite different from the and case where we actually have to check the second value, and that's what gets put, or test 1 gets pointed at. In this case, though, we don't have enough information for test 2, right? We have false on the left-hand side. So we actually are forced to kind of go over this gate, over this fence, and check this second value, and that gets put into test 2, or I should really say test 2 points at the string oranges. Okay. Similarly here, this is the same case with the or, because 0 is falsy. So we have to check oranges, and oranges gets put into test 3, or test 3 gets pointed at oranges. Okay. So a slight difference here. Between the and case and the or case. You're going to have to watch this a few times and actually code it out a few times, but eventually, hopefully, it'll click. So to wrap up the theory on this is this new funky operator, which is the Nullish Coalescing operator. This case down here, where we have a falsy value kind of messing with our statements, right, is probably not ideal. What if we only want to check for false or null or undefined, right? Maybe an empty string is true for us, or maybe 0 is true for us, right? It's a little bit weird that these values here are false, right? That's kind of strange. So what if we wanted a way to actually allow that to be the case, but allow us to actually check this just like we would with and or, and not have it kind of bug out this way? So that's what this Nullish Coalescing operator does. It works the same way as the or operator, but it actually allows for values that are falsy, like 0 and the empty quotes specifically, to be treated as true values. Okay, the actual false value, as you can see, is treated still as false, and so are null and undefined. Okay, so let's test these out really quick in Visual Studio Code. Okay, so I'll just create a new file here. I'll call this Boolean assignment.js. So let's go through these examples just to see what they look like. Let's start with the and case. So if I console.log, technically in this case we're doing the Boolean check, but we could actually assign it to a variable and then log it out. I'll just go with the shortcut here just to save us some time. If I do true, ampersand, ampersand, and then bananas, just like this, I'm going to run this file, and you can see that I actually get the string bananas. All right, that's because we check this. We have to check this second value, and that's what gets returned back to us. So we could actually have assigned this into a variable. Okay, so in fact, I'll show that to you. So if I go const fruit is equal to true, ampersand, ampersand, bananas, just like this, and I log out the fruit, you can see that this value that got logged out, so this second value actually gets, this is what fruit gets pointed at, so it gets kind of put into fruit. So if I run this, you'll see I still get bananas. Okay, I'll go with the short form going forward just so it's a bit easier and less keystrokes for me. If I do false, ampersand, ampersand, oranges, the string doesn't actually matter in this case. You can see I get false, okay? Because we know immediately that we don't need to check the second side because the first side is false with an and operator. And just to prove to you how the Nullish Coalescing operator is going to help us later, if I do 0, ampersand, ampersand, let's do cucumbers, right? I guess I wonder if that's not a fruit technically, but we get 0. This is because 0 is actually treated as false. Okay, so similar to this case right here, we're gonna return that right away, and we're gonna log that out. So this is basically false. We're gonna return it right away and log it out. So that's why we get a 0. Again, this is gonna take some getting used to. It takes quite a while. Even for me, looking at this is a bit confusing, but when we actually start using this in code in practice, it's gonna make much more sense. I just wanted to put this in here since we're going quite in depth into the Boolean operators, and this is the best place to put it. Let's look at the OR cases. So if I say console, ooh, my goodness. Let's look at the OR cases. So if I say console.log true or bananas, and I'll just put a line here just so that we can see this being split up. You can see that I get true, right? Unlike this case right here. And that's because for OR, if the left-hand side is true, we can return that right away. We don't actually have to check the right-hand side. All right. If I take this statement and I change this to an OR, false or oranges, and I run that, you can see that now I do have to check the right-hand side, right? So that's why it's giving us or evaluating to oranges, because we don't know whether this whole statement can be true yet. We're going to check the right-hand side and we're going to give back that value to us. This is, again, quite confusing because you'd expect these to evaluate to true or false. However, this is why this kind of goes under the assignment section instead of just the kind of true or false section independently. And finally, with the OR, I want to show that like we had 0 here, which is a falsy value, I'll just even do an empty string here, and I'll say cucumbers. You can see that we get cucumbers in this case, right? Because this is treated as false, just like here. So we have to check the right-hand side and we return that value. So to really wrap up this video, just to see the nullish coalescing operator and how it differs, if I take this statement or this statement, it's going to evaluate to the thing that we would expect it to evaluate to. So for example, if I do 0 or actually, let me change this to monkeys. I'll actually put this here as well. The nullish coalescing operator is question mark, question mark. So if I run this, we'll see that we get 0 back. Okay, and this is because this is being treated as truthy instead of falsy. Okay, with the OR case. So really to prove that to you, I'll do this, and let's do koalas. And if I change this from a OR to a nullish coalescing, this is now truthy as well. So we should get back the empty string. We're actually not going to see anything printed out because it's the terminal just kind of prints a blank line, but we actually have a blank line here, which is what this empty string is. We don't see koalas below the 0. So these are cases where the nullish coalescing helps us out a lot. And you can see that if we actually give a falsy value like null, undefined, or false itself, this will work just like the OR case. So if I say, for example, null, or let's just say elephants, right? And I just clear this out and I run this, you can see that I do get elephants, right? Because this is a falsy value. So I'm actually going to get this case. So in this case, it works just like it would with an actual OR statement. And you can see the empty line for the empty string there. Okay, so that kind of goes through all of these different operators, as well as kind of the more advanced use cases with the assignment operators. This assignment part, so these last 3 right here, are definitely a bit of a mind mush when you first go through them and first learn them. So don't get too worked up if it takes you a bit longer to go through these. When you actually see these being used in practice, for example, logging into a server or checking for a token, or actually getting values out of a database, all these kind of crazy sounding things are where these are actually used in practice. And then it makes much more sense when you actually have the context for it. I just want to bring these up here just as a reference. The most important parts of this video are these operators right here by themselves. Just comparing a left-hand side and right-hand side to each other, which we're going to see in the conditional section. please like this video and subscribe to the channel if you enjoyed this comment. As well, I'd love to hear anything you have to say in the comments section below. In the next video, what we're going to do together is do a problem set or a series of problem sets for all of these different operations, both the Boolean operators as well as the assignment version of them, just to kind of get a bit more practice, as well as some bonus questions in there as well. So if that sounds good, I'll see you in that video. Otherwise, what we're going to do is go straight to conditional statements, where we're actually going to make use of these to control the flow of our code. Super excited for that. I'll see you in those ones.